Hi, and welcome everybody to another AIA Colorado Virtual Connect on this beautiful spring day. We're glad you're with us. And today's session features a conversation on the decarbonization role that building materials play in greenhouse gas emissions. Presenters will investigate the current climate crisis, including the Intergovernmental Panel on Climate Change, IPCC goals established in 2015. I encourage you to use the chat box to ask questions. I'll help moderate the discussion after the presentation. In addition, AIA members will earn one AIA CES Health, Safety, and Welfare credit for participating in today's webinar. And now it's my pleasure to introduce today's speakers. First up, we have Gregory Kingsley, PhD and PE, who is the president and CEO of KLNA Inc., engineers and builders in Golden, Colorado. This 90-person firm includes structural engineers, civil engineers, land surveyors, steel detailers, and construction managers. Kingsley enjoys working with design architects on innovative structures, particularly wood. Welcome, Greg.
Thank you.
And next we have Victoria Herrero Garcia. She's a senior sustainability and carbon project manager for Ambient Energy. Victoria enjoys initiating embodied carbon conversations with design teams early in design and helps develop sustainability strategies to achieve carbon reductions. Herrero Garcia is co-chair of the Carbon Leadership Forum Rocky Mountain Hub. Welcome, Victoria.
Thank you.
Okay, I know you've got a jam-packed PowerPoint full of really interesting information, so we'll let you get to it, share screen, and I'll see you at the end.
All right, there we go. Thank you, Mike. Thanks very much. This is the title of the presentation that you saw in the AIA invitation, Decarbonization and Open Invitation. That's what it is. But in fact, as Victoria and I worked on this, we thought that this was a little bit boring, and we proposed a different title, which is Getting the Fish to See the Water. In my view, embodied carbon and the design problems around it have been around us and surrounding us all the time, but I've just been blissfully unaware that we were in the middle of that problem. And the idea of this presentation is to make you aware of some of this that's all around you and how that affects your life. Next. So I started out wanting to, or originally thinking I would give this presentation alone, but I've been working a lot with Ambient Energy and with Victoria, and I thought that bringing her on board would really help make this a more well-rounded presentation to architects. So glad we're taking this on together. Next. Our learning objectives to get in this presentation, we want to learn how to start a conversation about embodied carbon. It's about something that we're not used to talking about. To understand the implications of embodied carbon in structural systems and in building envelopes, building systems altogether, become familiar with tools and resources to reduce it, and then be able to communicate the value of design for embodied carbon to clients. The first and last starting the conversation and communicating are often the hardest. So what the agenda is going to look like is we'll start with the new built environment challenge that Victoria is going to talk about, and she'll dip into a case study for a one-story building as an example. Then I'm going to talk about the value proposition in another case study, and then looking at sequestered carbon in the built environment, which is different than embodied carbon. And then finally, a challenge to action and some questions at the end for you guys. First, we want you to listen to this inspiring message, just for a minute 28.
On Christmas Eve, 1968, astronaut Bill Anders snapped a photo of the Earth as Apollo 8 orbited the moon. Those three guys were surprised to see from their eyes what a planet looked like an Earth-wise, a blue orb hovering over the moon's gray horizon with deep oceans and silver skies. It was our world's first glance at itself, a first chance to see a shared reality, a declared stance, and a commonality, a glimpse into our planet's mirror. And as threats drew nearer, our own urgency became clearer as we realized that we hold nothing dearer than this floating body we all call home. We've known that we're caught in the throes of climactic changes some say will just go away, while some simply pray to survive another day. For it is the obscure, the oppressed, the poor who, when the disaster is declared done, still suffer more than anyone. Climate change is the single greatest challenge of our time. Of this, you're certainly aware. It's saddening, but I cannot spare you from knowing an inconvenient fact, because it's getting the facts straight that gets us to act and not to wait. Dream.
Okay, so that was something that Greg and I have found very inspiring. And of course, it's like there's a lot of polar bears that we have seen and a lot of images of climate change happening. But this is the greatest challenge of our time. And the new Built Environment Challenge is that we all have been working, ambient energy have been working for many years on operational carbon and reductions, and working with design teams to work on getting our buildings to be better or even net zero energy. But when we have projects already that they are high performance buildings, that they are reducing a huge amount of energy, and we started to see that there is another part of the pie that gets bigger and bigger the more efficient our buildings are getting, and that is related to embodied carbon. So what is embodied carbon? Embodied carbon is the emissions or the impacts of the materials from extraction to manufacturing to the end of life. And you might have heard already of these as global warming potential. So embodied carbon is also called global warming potential. The unit of measurement is kilograms of CO2 equivalent. And that is why it is equivalent, because it includes all 6 main greenhouse gases. Why is this important to us? Some of you might have seen already this slide or read an article about this. So it is estimated by Architecture 2030 that by year 2060, the world is projected to add 2.5 trillion square foot of buildings. That is 1 New York City each month for 39 years. And that is about 468 New York cities.
So I'm hoping you all will find this poem online and listen to the whole thing. We've picked a few lines out. And after that last slide, wanted to point out that we're not here to scare you, but to prepare you about what's going to change in our profession going forward. So next. Other direction, there we go. So how does it affect our design practice? Let's go ahead and move on to the next, Victoria. Okay, so really, in reality, I think the way that we're going to move this focus on embodied carbon forward is really going to start with legislation and requirements to do so. It doesn't have to start there, but that's going to be the ultimate goal. And I'm happy to say that there's a number of states, including Colorado, that are already working on it, that have bills introduced, and California has already accepted some. Next. So there's other also rating systems. Some I'm not going to name them all, but the ones that we're familiar with, LEED and Green Globes and ILFI, are all starting to incorporate more and more embodied carbon measurements as a part of the, in addition to the operational issues that we're used to. Next. So the 2030 challenge for embodied carbon was really actually my inspiration to get started with this, noting that AIA, the Architecture 2030 challenge, asked to reduce emissions to 0 by 2030 and embodied carbon emissions to 0 by 2040. Next. And then the structural engineers have finally gotten involved, and we have our own 2050 commitment to commit to zero embodied carbon by 2050. This again was the thing that really got us motivated at KLNA, and we were an early signature to this agreement. There's also an AIA mandate from 2019 from the CEO of AIA that basically put forward this, requirements for embodied carbon, which has been a source for us of basically laying out our plan for Team Carbon at KLNA. There's going to be a couple of website links that are on our, on that last slide and on these that will help you guys. The first one here is an interesting one because it's directed towards owners, and I think that that's really important to starting the conversation with owners. Maybe it's the most important thing, and then embodied carbon policies about the policy framework for cities themselves. Next.
So how do we even start? There are regulations, there are rating systems. Some rating systems or some regulations talk about product, other talks about reducing the entire embodied carbon in a building. So step by step, like we, a way to start is to look at a product level. So at product level, we have the environmental product declarations. These are created from an LCA, so a life cycle assessment of a product throughout the life of like the extraction, manufacturing, and once it leaves the gate, the manufacturing, it's over for the most part. And it is very important to know how to read these things, and I will walk you through a few steps. But one of them is called, like, the EPD is, you have heard most likely, the nutritional label of a product when it regards to environmental impacts. So it shows all the environmental impacts and the global warming potential. That is the one that we are focusing here the most. So how does the life cycle assessment work on an EPD? So there is a systems boundary. So that is what is included within that analysis. And as I already mentioned, it starts from extraction to the manufacturing. So it is called cradle to gate, because once it leaves the manufacturing process, the manufacturing gate, it ends. So that is also called life stage A1 through A3. So A1, A2, A3 is included in the EPDs. One example, it will be to grab an EPD of a product. In this case, I picked the Armstrong ceiling panels. And the first thing that you will look at is the declared unit. So declared units, in order to compare a product against another, you first need to make sure that the declared unit is the same. And then you can go and look at the global warming potential and then compare them if the declared unit is the same. There are additional things that that also make it a little bit more tricky on how to compare it. And that is why we recommend using these free available tools to everybody that compare actually EPDs from A1 through A3 life cycle stages. The reason why is because some EPDs include other stages, like end of life, carpeting, for example, includes some more. So these tools make sure that all the steps and all the declared units and everything are aligned, so you can compare them truly. Okay, so what do we do after we have all the EPD information? So we put it all together and we can do a whole building life cycle assessment. So that will be comparing a baseline building, like the type of building, and what is the normal construction for that type of building. So you create a baseline and then you compare it to the design case. And that normally for different rating systems, and this graph shows a project that we did for the Denver Zoo, and it has all the environmental impact categories. The most important one that we are discussing today is the global warming potential. So how do you compare them? What do you do to compare them? What is included? So a whole building LCA systems boundary includes from the materials extractions to transportation, maintenance and replacement, and the end of life. So that is A1 through C4 life cycle stages, and is called cradle to grave. For the most part, different rating systems have different mandates, but for the most part, 50 to 60 years is the building life cycle. So from when you start to the end is 60 years max. What tools do we use to do this type of analysis? Are Athena Impact Estimator, One-Click LCA, Tally, and eTool. The most commonly used in North America are the first three, and eTool is mostly used in Australia and England, New Zealand, and that part of the world. Okay, so here is one case study that Ambient Energy completed for a one-story building. This building was about 13,000 square feet. We were in concept design. That image was a little bit farther, but in concept design, we got together with the architect and the structural engineer, and we used this tool called Carbon Designer that is from One-Click LCA, and it has this little screen is what you see at the beginning is the interface, and you have the inputs of your building type and your climate zone, and then kind of like picks and chooses with a square footage if you have different ground slabs or not, like what are you going to do with your projects, staircases, balconies, and then it generates the results. There are a lot of assumptions. This is not like perfect science, but it is based on the climate zone. So building type, climate zone, and normal construction type for that type of building. So when we looked at this concept design, the architect was like, wow, what is happening with the underground walls? I didn't know that the underground walls had such a big impact, and the roof slab. But so the design team needed to, by code, we needed to have underground walls to have a crawl space for this one-story building. So it was kind of like started the conversation of what can we do? So let's see what happens if we raise the building up. So that is what we did for the proposed case, or the optimized case. So the blue bars are the baseline and the gray bars are the optimized case. So you see that the underground walls, in this case, we made them disappear. So great, we reduced 15%. But then we were like, okay, what can we do with the roof slab? What type of roof slab is assuming that we are going to have? So pretty standard metal deck and concrete with insulation R30. So we decided to make this change and use a wood frame roof system. And with that same R value for the roof. And then we had the reductions, further reductions, that went more than 40% down from the baseline. But this was all like estimated numbers and assumptions and a lot of like things that we didn't know. So then we decided to just do an LCA for these two options and combine them. So we did a standard foundation with a steel roof framing and a standard foundation with wood roof system, and the same like elevated foundation with a steel or wood. And what we found You can see like the baseline was the standard foundation and steel, because that was what we created. And then we found that just changing that standard foundation, but the wood roof deck, then it will be more than like close 70% reductions, 30% reduction, sorry, to 70% emissions. And then we also looked at the structural level, so like elevated plus wood, and we found that we were really close to the 40%, that it was the estimated, it was 45%, but we were pretty close as well. And this was only the structure. So now you all architects might be thinking right now, like, okay, so this is all the structural engineer's fault. It's nothing has to do with me, and I would just leave it to them to fix this issue. But according to this graph, this was an analysis completed by Deloitte, and the lifetime of the building is 100 years, which is uncommon. But they did this study for that long, and they found out that initially the embodied carbon of their project was going to be 46,000 tons of CO2 equivalent. But what they didn't realize is that along the life cycle of the building, the lifetime of the building, the maintenance was accounting for 40,000 tons of CO2. So this is a big role that everybody plays in the equation. Yes, the structure might be the first most impactful thing at the beginning, but we all have to make the right decisions and reduce the embodied carbon of our products.
Excellent. Another line that we picked out of the poem that I just zeroed in on is "we refuse to lose." It takes a little bit of attitude to push through this. We take the same approach that Ambient does in analyzing buildings early on to try to reduce the carbon. But the challenge that I run into is the owners that we're working with, they ultimately want to know what's in it for me. Next. So the value proposition is really the key. In the next slide, Victoria. So let me start with kind of the intangibles, the sort of the fuzzy stuff that, you know, if you're doing the right thing and following these kind of designs, hopefully you'll be increasing customer loyalty, employee relations, you're innovating, you get media coverage, all these kinds of things in turn then drive greater profitability. And then that in turn drives or delivers short and long-term value creation for shareholders and society. But these are kind of fuzzy things to get a hold of. What the owners we're working with want to know is, what is this going to cost me first off? If you read Bill Gates' book, he talks about a green premium, what you're going to pay to do the right thing. And I like to think that a lot of what we're doing can be done for no cost. Go ahead to the next slide. That's fine. The Microsoft quote is good. This is them, you know, basically at Microsoft pointing out that they were able to procure materials that met their reduction targets with zero cost premium. And ultimately that's the goal that we have to get to zero premium, not just zero carbon. Next. So let me talk about just different materials that we work with usually, concrete, steel, and wood, and what we need to do if we want to lower the global warming potential of each and how that affects the cost. So starting with concrete, if I want to lower the global warming potential, next slide, to reduce the GWP, the main thing I'm going to do is reduce the volume of concrete and reduce the amount of cement. I'm going to replace that with supplemental cementitious materials. And usually, not always, but most of the time, those moves to reduce embodied carbon are also going to reduce the cost. So while it's not always true, usually you can say if I'm designing an efficient concrete structure, I'm probably doing the right thing for the environment as well. For a steel structure, if I want to reduce the GWP, again, I'm going to reduce the steel tonnage. I'm also going to increase the amount of recycled steel, or what we're focused on is actually just reuse of steel pieces from other jobs or demolished jobs. And the cost of that may or may not be more or less expensive, depends on the project. And then my favorite material these days is wood or mass timber, and I can dramatically lower the GWP by using that. But the challenge is that I do that by increasing wood volume, and when that happens, I'm almost invariably increasing the cost. So there's a big challenge there. So what I'd like to do is talk about some case studies that we've done, and they're really focused in on wood structures because that's kind of my current obsession, if you will. And this first case study I'm looking at is just a few bays of a generic structure. And we were looking at all the different building types that you can use with mass timber. And that starts with 3B, which is limited to 4 stories, and then 3A, which is limited to 6, and so on, up through the new type 4C, B, and A that go to 9, 12, and 18 stories. And so we just designed a typical bay for each one of those building types and each one of those story types. And we looked at then what the global warming potential was for each one of those. And that's the graph that you see on the right there. Shows the global warming potential working from 3B up to 4A. And you can see 4B has the most amount of timber. And so that's the one that has the greatest unit global warming, that's the highest global warming potential per square foot of the different systems. It also has more gypboard and more concrete than the other ones, so I kind of got that inverted. But the next slide is going to show you where the real value of the wood structure is, and that is in the concept of sequestered carbon. So wood itself is about 50% carbon, and if we take that into account with the global warming potential, we actually end up with a total negative number. And this is where the higher volume structures in 4C and 4B really shine, okay? But so for the environment, this is clearly what I want to do, but what's that going to affect? How's that going to affect my cost? Next slide. So we also took these same studies and did some relatively simple cost analysis. And we looked at the cost per square foot in this slide of the same systems. And you can see as you go from the type 3B up to 4B, 4A, and so on, the unit cost actually goes up, mainly because of the fire rating for the timber and the non-combustible coverings that you have to put on and so on. All that makes the taller structures more expensive per square foot, just not more expensive overall. So, so that's a challenge for my owners. Well, what can we do about that? What if we actually got a credit for the carbon that we were storing in the building? And this is where I like to share a slide from a firm called Aureus Earth that's run by Will Schrubar and a couple of other folks. Will is just from University of Colorado in Boulder. He's an old friend. And they've created the world's first carbon marketplace for buildings. And it's a fairly involved process. But at the end of the day, what it means is if you work with Aureus Earth from the beginning with the kind of case study that Victoria just showed you earlier, they can assign a value to the carbon that you save and the choices that you make and actually sell that to a corporate buyer that's looking to lower their carbon footprint and take that money back to the owner. Next slide. So the carbon credit for these same buildings is shown on the right. This is not on the same scale. I want to emphasize on the left, we go all the way up to $60 a square foot. And on the right, we're down in the $1 and $2, $3 a square foot zone. These are lower bounds. So I don't want to suggest that the premium for using wood structures is going to be made up with the carbon credit. But if we're looking at a 100,000 square foot project and you can get $2 a square foot, well, that's some real money to put in your pocket and no one would laugh at that in terms of budget. So I think that's a really encouraging thing for us all to point to as we're looking to really maximize sequestered carbon. Next. So now I want to talk a little bit about another case study that we did for Platte 15. This is a building that we built down across from my brother's bar at the corner of 15th and Platte. Next. So this building, this study we actually did for Think Wood, and the building importantly has 2 concrete floors below grade, and those floors are mostly under the water table, which will matter in the analysis I'm going to show you. There's 1 PT slab above grade, and then 3 floors and a roof in mass timber. Next. So what the Think Wood folks asked us to do was compare the mass timber structural system that we actually designed with the steel one that we actually designed early on for an early cost study. And then we actually added a PT concrete structure that we might not normally have used, but we just wanted to do an apples to apples comparison on the same building. And they wanted to compare the global warming potential and the cost for these buildings. Next. So the first thing that we learned was that with all that concrete below grade and a mat slab and everything we're doing to hold that building underwater, the GWP was absolutely overwhelmingly dominated by the below grade concrete. Interestingly, this is the same conclusion that Victoria found for their one-story building. The below grade structure really added up. So in the analysis I'm going to show, you'll see these diagrams. Some include the whole building, but most of them include just the building above grade, so we can get a more apples to apples comparison between the materials. Next. So on the left, I'm showing the global warming potential for each of the 3 building types for the whole building structure. And the gray part of the bar represents the concrete, the blue represents the steel, and the green, which you can't see because it's so small, represents the global warming potential of the wood. On the right, we try to make a little bit fairer comparison with just the above grade structure, and the same colors apply. The gray is the concrete, the blue is the steel, and the green, again, which you can barely see, is the timber. And you can see all of them are really dominated. Even the mass timber system is dominated by just the topping concrete and the amount of concrete that's in the elevator cores and so on above grade. Even the steel system is dominated by the concrete number. So that tells us where we need to focus. Next. So you saw a graph just like this one in our first case study, and it shows how the global warming potential distributes through the different phases or cycles that we count in our whole building LCA, or in this case, just a superstructure LCA. And of course, it's dominated at the front by the A1 through A3 phase, which is the main construction piece. But it's interesting that that there's this sort of bar that pokes up at the end. So you end up having a lot of conversation about end of life. At KLNA, we use Tally, and Tally makes some assumptions about what happens in the end of life for different materials. And for wood, it assumes like 65% of that wood at the end of life is going to go into landfill, 17% will be incinerated, and another 17% will be saved. While in my opinion, I think the wood structure is most likely to be able to be reused at the end of the life. That's not the base assumption. So that's where that, or at least in Tally anyway, and you'll see it's different in different softwares. So that's where that comes from. But it still tells us to pay attention to that as part of design, which we think is important. Next. So this one shows the all the different modules in the life cycle analysis, and the end of life stage is significant. So we take an attitude we call long life and loose fit. I didn't make up that term. I just like it because it makes me think of an old pair of jeans. The idea is to actually, in the design of the structure, to design it with the 50-year mark in mind, at which point we might deconstruct the building and be able to reuse the pieces. So you want it to come apart as easily as it goes together. Next slide, please. Now, let's talk about dollar cost for those same 3 buildings, okay? So we had Adelson and Peterson worked with us. They built the original structure, and they went ahead and got pricing here a couple of years ago for the 2 other steel and concrete structures. And when we made that comparison, and here, by the way, I'm just showing the above grade structure, just sort of to emphasize the difference, because the below grade is identical for all of them. It turned out that the steel system was the cheapest. So that I'm showing as 0. And I've normalized the concrete and the timber to that as a percentage increase over steel. So the concrete structure was 3.25% more expensive just for the superstructure over the steel. And the timber was a whopping 8% more. And sometimes you find with mass timber structures that it's even more. I mean, I've seen numbers in the realm of 15%, okay? And this is often where a mass timber structure just dies on the vine because that superstructure cost premium is perceived as too much. But the other thing Adelson and Peterson knew from building this building was that they saved several months of construction time with the prefabricated nature of the mass timber. And if you take that into account and include the labor portion of general conditions and the equipment and crane time part of general requirements and urban site logistics that were all true for Plat 15, then actually that premium drops down. It's actually increases a little bit for concrete, but we cut the premium for the mass timber in half. If we take another step and look at the whole building cost, where the structure in this case was about 15% of the overall building cost, what you're looking at is the premium in this case for timber is about 2% or less than 2% over the low cost steel structure. So now you're starting to get into a point where you might be able to have a conversation about that, and maybe that Aureus Earth carbon credit would start to close the gap a little bit. Next slide. So my final slide on this case study is just about, I'm trying to compare in one slide all those things, the GWP and the cost. And in this case, I'm looking just above grade, and I've normalized everything to the GWP and the cost of the mass timber structure. So both of those show on the left at 100%. And then the GWP for the steel structure is about 330%, or about 330% of the wood one. And the concrete is up over 400% of the wood one in terms of GWP. In terms of cost, it's really hard to see on this scale, but there is a little gap there that shows both the steel and the concrete a little bit cheaper than the wood. And while it looks really small in this graph, I don't want to undermine it, right? If that's, it could be, for a significant size structure of this size, it could be $1 million, and so it needs to be paid attention to. But I do find it encouraging the bang for the buck we can get if we pay attention to how we price out the mass timber structure. So with that, we'll move on to Victoria's last piece.
Okay, thanks, Greg. So with all these, again, another piece of the poem that always catch our attention is which inspires us to ask deeply, Holly, what can we do? There is something that we can do, right? Is opening your eyes to solutions is a great first step. So with all these, there's like, I don't know, overwhelming numbers that come from the Intergovernmental Panel and all these climate action plans and all this information that we are bombarded by. And it seems like there is no real time. I get myself sometimes overwhelmed and thinking that this is not even possible, but it is very encouraging. We put the link already to the Carbon Leadership Forum. There will be another link coming up here. But there are some amazing people researching a lot of stuff out there, trying to get the industry to move faster. And one of the faster moving options are materials that sequester carbon. So what are those and how do they really work and make sense? So on this graph, there is a lot of information. I want you to center on the blue line in the middle up. So everything that is on red, that will be any construction material as we know it right now. So no wood, no wood or not any photosynthetic material or biogenic. That will be on the green side at the bottom. So the red, if we go to the red and we go to the harvest, it seems like everything keeps going up, and between the harvest and the manufacturing, related to the graph that Greg shows too, from A1 through A3 are the biggest impacts. So that's why the biggest step is through harvest and manufacturing. Then transportation is big too, and construction. So those are all the life stages for that building. And then is through the lifespan of the building and the end of life with the landfill or recycling. So those are all emissions that they are out there. Our building build as usual is emitting, is not storing any carbon. So what options do we have? If we look at anything that is photosynthetic or biogenic material, that means that we plant them, so it has some emissions during the planting time. So that's why it's on the top part of that middle line on the blue. And then throughout the life of that product, let's say wood, let's say hemp or bamboo, anything that is photosynthetic, it keeps going down because it's storing carbon. Then what happens is we harvest it, we manufacture, we transport, and we construct our building with that material and other possible other materials. So that keeps going up again, but we're still below that blue line. So that blue line is like the zero threshold. And what it goes to the end of life, yes, there can be the worst case scenario that it goes to the landfill or it gets incinerated or anything that will create more emissions. But if we can build buildings that will stay below the blue line, instead of emitters, they will be carbon sinks. And that is what we are all striving for before it's too late. Then one example of this type of materials. So this paper that I'm gonna mention in the next slide too talks about carbon storing materials, and it gives you like steps and different materials options. And one of the things that it talks about is what can we do now? So in 1 year, and it seems like overwhelming to do too much, but right now is product to product, like procurement, selecting products with low carbon or carbon sinks that will help to reduce the emissions, the overall emissions of our buildings. And that is using EPDs and comparing apples to apples. So then if we use, for this example, is insulation, and there is the units are all, this study was done in Canada, so it is all metric system, but it's an R value of 20 that is a standard for everyone. And comparing to the different insulation types, we see that hempcrete actually is not that it emits any, that zero line of emitters versus carbon sinks. It is very helpful to get to that point. So as simple as that, just replacing one material, it helps the overall performance of or emissions of our buildings. So material opportunities, here is the link to this carbon storing materials paper or research paper that was completed by the Carbon Leadership Forum. And this image represents all kinds of different things. It is not exactly all from what is on the paper, but what this paper talks is about bio-based materials and mineral-based materials. And with the bio-based, it doesn't have to always be hempcrete or wood that we grow, bamboo, but also there is a lot of opportunity for bio-waste and agricultural waste, like cork and straw and coconut core and rice hulls and all these things that they are developing, they are not readily available. So this is like the next step, and then they call the quantum step or the quantum jump to the maximize these emissions or creating carbon sinks for our buildings. So there are a lot of things out there, and there are a lot of resources to look at, but most important is that we start looking at what can we do now, and then what can happen within the short term and what we need to do for the longer term. So as Amanda Gorman again says, and I hope you don't take this image as an angry, like we have to do it now. It's more of an energetic, like there is no rehearsal. The time is now. Now is when we have to act. Now is when we have to think. Now is when the conversations needs to start. So what can we all do as architects? So the first thing it will be to educate clients, then consider building reuse versus new construction. And that is included, as Greg mentioned, in some of the rating systems also. But even if you're not following a rating system, always consider these options. Engage a structural engineer and contractor early in design. It is very important to analyze all these options, as Greg was showing and my case study was showing, but then have the contractor really to put numbers to these options. Then analyze reductions early in design. Research carbon storing materials. So maybe one at a time, for one project. For another project, maybe wood cannot be the case, but maybe the insulation can be the option, or interior materials, carpeting, better options for gypsum board, anything. Then foster collaboration. This is a key thing that I want to come back to what Greg mentioned at the beginning, like KLNA and ambient energy. We now have two projects that we are starting to work together. And we have worked in the past together, but lately we have not really worked in embodied carbon until these coming projects. And but with the Carbon Leadership Forum, Rocky Mountain Hub, we started to make connections, and we started to discuss and how important it was for the two of our companies to spread the word. And that's why we are together here collaborating and spreading the dialogue among all disciplines. And in this paper, the carbon storing materials, there's a really good sentence that is leadership, in the category leadership, and it says, set a new and disruptive business as usual standard. That is what I'm throwing to all of you right now, what Greg and I want to have in your heads, like, how can you start doing this, and how can you start moving this forward? And with that, we want to send a question to you all. And that is, what are the challenges to make this happen in your practice after you have heard all this information, plus all the information that you might have from before? What is stopping you? What can we do? So I think we're gonna open to questions. And also, but before, we would like you to answer to this question in the chat. So please go to the chat and type your answers. And I think, Michael, you're gonna, and I am going to, we will share this with you all. I'm just gonna stop my presentation, because I cannot see anybody. So I'm gonna, if that is okay. Is that okay, Michael, Greg?
Yes.
If I stop, okay. I cannot see the cameras now. I see you all. Hi.
Thanks, Victoria and Greg. That was fascinating and packed with information. So just as we're getting responses into your question, which is a good one, Julian says, educating clients is the biggest challenge we face. And I'm sure he is not alone in that comment. So please, other participants, share your answer to that question as well. And then I'll get into some of the questions and comments that we've had over the course of the presentation. There's actually been a lot of conversation here in the chat and on the Q&A about, you know, wood and how that is changing in terms of the market and the cost per square foot. So I'll dive right in. Brooke says that she participated in another session about embodied carbon, and the developer noted that CLT structure ended up being higher carbon footprint due to the wood shipping from Europe because it had a lower cost to be sourced from there. Have you had any similar experiences where the source skews the carbon footprint of the wood frame building to be higher than the metal framed one?
So I'll take that one. And, you know, I haven't had that experience directly, although we definitely encourage people to buy local, if you will, in North America. So to actually just for that exact purpose, to lower the transportation costs. But Europe has come in, you know, a lot cheaper because they're, you know, much more advanced in terms of their manufacturing capability and so on. So it's certainly tempting. One question that I would ask though is just, you know, this whole process of understanding what the embodied carbon footprint is a pretty complex one. So it looks like a simple question, but it's kind of a big wormhole in my mind. Like there was a slide that Victoria showed that included photosynthetic drawdown, right? And included or attempted to include in some conceptual way the whole forest ecology part of the process, and also the notion of sequestered carbon. So if you're just measuring GWP, that wouldn't surprise me at all that the wood structure would exceed the metal structure with that large transportation piece. But if you're including sequestered carbon, maybe it wouldn't. And then, and that's really as far as we can go in terms of what we can measure ourselves and the tools that we have. But if you're really thinking large, in my mind, it may seem counterintuitive, but in my mind, the goal is to increase the number of forests because that's where the real sequestered carbon is. And in my view, the best way to do that is to create a market for the wood so that we can plant more forests. My friend Katie Fernholz likes to say, if you want really good apples, the way you get them is you buy apples and then farmers plant apple trees, right? And it's the same with trees. So really, there's a big question there about what's the right thing to do. And I tend to think just from the starting point, without getting lost in the details, building by building, that if I'm encouraging someone to grow more forest, I'm probably doing the right thing.
Yeah. Really interesting take there, Greg. Thanks for sharing that. We get a related question that wasn't about the transportation impact, but about the commodity pricing. And I know you answered that directly, but I thought I'd let the rest of the participants know. Rosie asked that with timber being a commodity and pricing going up and down all the time, especially right now, of course, were the timber numbers you shared based on recent COVID pricing or pre-COVID figures?
So that was all pre-COVID numbers, and we have a relatively short presentation here, but usually when I present these numbers, I spend 2 or 3 slides telling everybody that all of these materials are commodities and the prices swing wildly up and down, especially as they are right now. So it's an excellent question, and it's really literally right on the money. But at the same time, the value proposition that I'm trying to focus on has more to do with the time savings in prefabricated construction and what that means in terms of the overall cost. And I think the conclusions that I draw about that remain valid, even if the percentage numbers are going to go up and down depending on commodity prices and so on. So it might not be exactly true to the same level that I'm talking about for every building and every material. But I think if you keep in mind speed of construction as the driver of some of these significant costs, that regardless of commodity prices, you can still find an advantage, hopefully.
Just a few more comments I want to share in answer to your question. Anna says, finding resources and options out there is the biggest challenge. Margarita says, understanding the benefits of the long-term investment. So those are a couple more that have come in. I'll share them as they get added to the chat. Another question, Julian says, the UK has been researching CLT vibrations without a concrete topping to avoid the embodied carbon in the topping. Is there any US research on this topic that you're aware of?
Good question, Julian, and my answer is not enough. This is an area that needs a ton of research because that vibration, it pretty much drives the design of mass timber panel system structures, whether it's CLT or dowel laminated timber or mass plywood, whatever you're looking at, vibration drives it. And there is just not enough information for us to be as efficient as we need to be in optimizing materials. So sadly needed. That said, I'm also seeing a number of projects without concrete topping that are successful. One that comes to mind immediately is the Soto project by Lake Flato in San Antonio that has a raised floor, which also increases cost a little bit, I'm sure. But the challenge with CLT is that you can't expose the floor directly because it's softwood. It's not that durable, in terms of a walking surface. It creates acoustic challenges, primarily those two. You need something above the CLT surface above, right? And then, but yeah, hopefully getting rid of the concrete topping becomes a goal of the industry.
Rosie comments that time, budgets, and schedules are big challenges. Again, probably not the only person who runs into that. Victoria, I really appreciated what you shared on some of the carbon impacts long-term. And of course, everybody's heard the concept of first costs versus long-term costs. I've never really understood that maintenance over the life cycle of a building is such a huge contributor, and you really were able to show that. Is there anything that architects and designers can do about material selection that might impact maintenance long-term?
Yes. So again, the procurement side of already starting to specify products that they have low carbon or zero carbon. There's some carpet products, for example, out there that they are started to claim close to zero carbon because of the end life use interface, for example, is one of the companies that they are working really hard on that. So I will encourage all architects and interior designers to look at the EC3 tool. Is the Building Transparency is the website, buildingtransparency.org, and then it will, but if you search for EC3 tool, you will find it. And so first of all, like, design for adaptability, of course, and try to design a building that could be retrofit and changed, but at the same time, it could be adapted to something different. So you reduce the amount, so it will be building reuse again. So reduce the amount of drywall or interior partitions to be demolished. So make things that can be moved or removed, like modular construction type interior, and then material selection, of course. So the two things, like design for adaptability and building reuse, and the end of life of any of the products that you select that can be reused or repurposed. And then procurement specifications, pretty much, like make sure that if it's going to be a building that will have tenants throughout the lifespan, make sure that there is some design guidelines that mentions that you need to procure low carbon material products because this is what it was designed for. And yeah, I think I would recommend those things.
Yeah, it's that long life, loose fit concept. But also not just the operational maintenance of the building and its systems, but the day-to-day over the life of the facility. Thinking about that as well. You don't need a building engineer for some of these things, and oftentimes it gets overlooked when we are in that phase. So some good user manuals might be helpful.
And we put the information. There's I think all of you are going to find this very valuable, the resource from the Carbon Leadership Forum. So search, we will have it on the slide deck, but Carbon Leadership Forum owner toolkit, and there is 3 to 4 pages document. One is like how to talk to, thank you, Brenda, she just put it on the chat. So how to talk to the owners or the clients, and the other one is procurement, and the other one is targeting net zero, how to get there. So there is like 3 documents. They are planning on developing other resources, their policies. There's a lot of good information there.
And it's a chance for optimism that it's not something we have to face alone, because you're seeing a lot of owners get more interested in this. You're seeing public sector entities like mayors and university presidents Even when the U.S. Withdrew from the Paris Agreement, there were other groups that said we're still in. So you may find a more willing audience than you initially expect to find when you start working on these issues. And just on that note about further resources, we will have this session recorded, and it's going to be made available to all attendees, so you can review it later and see any part of the presentation to get more of those resources. And then I believe we've got a member of our editorial committee who's taking notes, and there will be a website recap on this as well. So that comes with all of the sessions we do for our attendees, and there's a lot of stuff that people I'm sure will want to go back to and dig a little deeper on. So Greg and Victoria, this was really inspiring, but also actionable, and I certainly appreciate that. The one follow-up note here is the recording will be posted on the AIA Colorado YouTube page. It usually takes a few days, so probably by the following Monday, we'll have it up there. So watch for that. And then I want to do some closing notes here as we wrap up. So a big thanks to Greg and KLNA for being industry partners with AIA Colorado this year. And of course, Ambient Energy has been an industry partner in the past. So not only are they providing this really insightful information, they're helping to make this content free for all of our members and provide a whole lot of other services that AIA does for the profession. So especially thanks for that, your continuing commitment. And then we've got future virtual connects coming up. You can visit our calendar at aiacolorado.org to see that schedule. Next Wednesday, we'll let you know that the virtual connect is on becoming an architect, AXP, ARE, and Colorado licensure. It will be led by our two licensing advisors for the state of Colorado. And then on May 26th, the week after, we have a presentation on fire and smoke separation. And that'll be brought to you by Powers Products. So we hope to see you in the future. Again, thanks, Victoria. Thanks, Greg. And if you want to contact them for more information, that contact information was at the end of the presentation too. You can go back and review.
Thank you very much.
Thank you.
Take care, everybody.